In today's lesson, we're going to be finding the area and perimeter of polygons on the coordinate plane. It's going to be similar to what we did last time, but it's going to be different because they're going to give us the shape, and we're going to have to find the area and sometimes the perimeter as well. Okay, let's take a look at example number 1. It says, Jazit has made a scale drawing of a vegetable garden she plans to make in her backyard. She needs to determine the perimeter and area to know how much fencing and dirt to purchase. The fencing would be the perimeter and the dirt would be the area. Determine both the perimeter and area. We'll kind of focus in here. Okay, so we need to find the perimeter and the area. All right, let's take a look at the shape. This is her garden. Looks like she's a pretty good sized garden here. Okay, these are kind of hard to see because they're kind of little. Let me zoom in just a tad, but I need to be able to write on the side too. Okay, well let's find the perimeter first. To do that, we're going to need to find the distance all the way around her garden for her fence. Now, when I look at this, I see that this side plus this side is going to give me this whole side. So instead of finding this one and this one and this one, I'm going to find this one and this one and determine this one based on my addition. Same thing goes here. This side and this side together will equal that side. I'll help you out. First, let's make ourselves a little key so that we have what we need. These are line segments, AB, BC, CD, DE, and so on, all the way across. So I'm going to make my list over here. Line segment AB equals line segment BC, C, D, D, E, and I'm going to keep going until I've gone all the way around my shape. So go ahead and do that for me. All right, I'm going to my equal sign beside each one. Okay, now I'm going to find the distance from A to B. And to do that, all we can do is count. So let's count. Here's 1, 2, 3, 4. So that's 4 units. All right, and now the next one I want to find is CD, because I'm going to work just on these horizontal ones. I can skip around. I've got my place for my answers over here. So I'm going to find CD. Make sure I write it in the right place over there. So I'm going to go 1, 2, 3, 4. C and D is 4 units. Make sure you put it by CD, not BC. We skipped that one. Now, I know those two, and if I put those two together, I'm going to find EF. Okay, so 4 and 4 makes 8. Then I can double check, which I don't need to, but I can. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And now let's do the other ones. So I'm going to switch colors here so we can see the difference. BC is going to be the sum of the vertical ones. So we're going to count that one. 1, 2, 3, 4, 5, 6, 7. So that one is 7 units. I did the orange ones because these two orange ones go with that one. And then these two blue ones are going to go with that one. Okay, so then D to E. 1, 2, 3, 4, 5, 6 units. And if I put my 7 and my 6 together, I'm going to get this one, which is 13 units. That saves us a lot of counting of little itty-bitty boxes there. Okay, now let's do some addition. Okay, I'm going to add these all up. Since there are several of them, I could just add them. I'm going to go ahead and use my calculator. When we do geometry, a lot of times we use the calculator. So I'm going to do the 4, the 4, and the 8. Okay, because I can do that in my head. 4 and 4 is 8, and 8 makes 16. So I'm going to keep that number. Okay, now I don't have to think about that anymore. 7 and 6 makes 13, and 13 more. It's 42 units. That's our perimeter. 42 units. Now it's not squared because it's length. It's a fence. A fence is just a line. So a line can't be squared, it's just a straight line. So 42 units is our perimeter. Squish that in there. Perimeter is 42 units. Okay, now to find our area. I believe we're going to need to split this shape. So let's split it right across here. We could split it here. Let me do it this way. We could split it here. Can you see that? Or we could split it here. I'm kind of liking that one better, I think, to split there. So let's do that. You could do either way. If you split it the other way for yours, you would find different numbers and not be absolutely positive that it was correct. So let's, for this sake, let's do this one. Okay, now I can use what I have over here to help me a little bit. Okay, so I know from B to C is going to be my, let's find this one, let's number them, 1, 2. Okay, so for 1, rectangle 1, base times height, because we're finding area. Okay, so from A to B is going to be 4, so that's going to be our base, times our height was B to C, 7. 4 times 7 is 28 units, and this is area, so it is squared. That's part of our answer. Okay, let's do rectangle 2. Formula is still base times height, and we're going from D to E and E to F. So this will be our base because it's sitting on it. So EF is 8 units, so 8 is our base, times our height is DE, 6 units. 8 times 6 is 48 units squared. Okay, when we put those two together, it's going to give us the area, and since I have my calculator handy, I'm going to go ahead and add them on here. 28 plus 48. Definitely we could do that on paper, but we now have 78 units squared. So our area, I'm just going to put it over here with the perimeter, area equals 76, I said, 76 units squared. Okay, and I like how we already had these written out. I didn't have to count them again when I found the distance over here to find my base and my height for my area. Very good. Okay, let's do the next one. The next one says, keep that calculator handy, I might need it. Calculate the area of the polygon using 2 different methods. Okay, so we're going to do one method on here, and then I have another one for the second method. Okay, write 2 expressions to represent the 2 methods and compare the structure of the expressions. So we're going to do the expressions, which are going to be very complex, but we will do them to see what they look like. Okay, so the first way we can split this, I'm wondering about some triangles. What if we went from F to B? There's a triangle. If we went from F to C, that would give us another triangle here. And then F to D would give us another triangle here and then one down there. Ooh, let's do that. I'm going to zoom in quite a bit so as I draw my lines you can see where I'm going with them. And then I'll zoom back out to do the work. Okay. Let's flip this in a little bit here. From F to B, and I'm going to have to do it this way. F to B, it's kind of little, but I'll line it up the best that I can. I'm just going to do a bunch of triangles. Find some area. That's all we need. We don't need the perimeter of this one, she said. F to C, F to D. Wow, look at all those triangles. I'm going to give you a hint, if I can. This one, let's number them, because that's helpful to know which one we're talking about. 1 and 4 should be identical. 2 and 3 should be identical. So if we find this one, we just add it again. If we find this one, we just add it again. Let's make sure. Okay, so if this is our base, they share the same base, so let's make sure their height is the same. 1, 2, 3 up to that line. Okay, 1, 2, 3 to that line. So these two are definitely identical. Let's check these. The base is the same because that base and that base are identical. So let's check our height, which is going to be from here down to the center line we drew. Okay, I'm going to do it out here because I can see it better. 1, 2, 3, and 1, 2, 3. All right, so we know that the 1 and 4 are identical, and 2 and 3 are identical. So we only really have to find the area of 2 of them and then add them again. Okay, I'm going to zoom back out to do the math so that we can see what we're doing. Okay, so let's find the area of triangle 1. Formula is 1/2 base times height. I think my brain is starting to remember that because we've done it so much. Okay, so base was 1, 2, 3, 4. So we have 1/2 of 4 times, what's that, 3? 1, 2, 3? Okay, so half of 4 is 2. 2 times 3 is 6 units squared. And then that was the same for triangle 4. So I'm going to put triangle 4 equals 6 units squared. We already did the work, so we don't have to do it again. Those are parts of my answer. Okay, let's do it over here. Let's do triangle 2. Half base times height. So we have 1/2 of our base, and this base is this big long one right through here. So we have 1, 2, 3, 4, 5, 6, 7, 8. Let me double check. I'm going to go down from F where I can see the line better and go all the way to the end. 1, 2, 3, 4, 5, 6, 7, 8. Yes, that's a hard one to see because it's so tiny. All right, and our height, I think we said was 3. Let me check. 1, 2, 3. Yes. All right, half of 8 is 4, and 4 times 3 is 12 units squared. Okay, so that is triangle 2, and we know that triangle 3 is exactly the same. No point in doing the work again. Now we can add them up. Okay, so we have 6 and 6 is 12. 12 and 12 is 24. Forgot my squared over here. 24 and 12. Let's add them. 4 and 2 makes 6. 2 and 1 makes 3. So 36 units squared. All right. Now we have to write. We have to write a formula or an expression. Okay. Well, over here we did this right here, and we did 2 of them, right? Or 2 of those. And then over here, we did this, and we did 2 of them. Okay, so here's what we're going to do. It's going to be 2, this is going to be tricky, times the quantity, because we want to do this first, and then multiply by 2. Okay, we did 1/2 times 4 times 3. Okay, over here, we did the same thing. We did 2 of the 1/2 times 8 times 3, and then at the end, we added them together. This is our expression. Isn't that awesome? That's a very complex expression. Wow. Okay, I'm going to set this one to the side for a moment. We're going to do the exact same shape. We should get the exact same answer, but let's look at a different expression. Okay, so I'm going to set that one to the side. Keep it handy so we can bring it back out. This is the exact same problem. We just need a different way to do it. I think let's use that method that we used in another problem a while back, where we draw the box on the outside, and then we find the area of the other pieces and pull out the outside pieces to find the middle. I think it'll make sense as we go. Okay, I'm going to go ahead and put my point where A and F would meet out here, and B and C, D and C, I almost messed that one up, and E and F. Okay, so I'm going to draw my box around it. This is a different method. Should get us the same answer because we know that area is 36 units squared, so we should get the same answer. Let's see. Go ahead and continue this box all the way around. And right at the very edge of our polygon. All right, now if we find the area of each of those 4 triangles, then we can subtract out those from the square or the rectangle and find the area of the polygon inside. Okay, so 2 steps. Only two steps, can you believe it? First step, we're going to find the area of the rectangle. Then we're going to find the area of these. Then we're going to subtract. I guess there's 3 steps because we have to subtract. Oh, sorry. Okay. But let's look at each of these triangles because I think they have something in common. Let's see. The base would be 1, 2. The height is 1, 2, 3. The base is 1, 2. The height is 1, 2, 3. Base, 2. Height, 3. Base, 2. Height, 3. They're identical, all 4 of them. So whatever we do, we're just going to do it 4 times and have the same answer. Oh, amazing. That's why there's only a few different steps. Okay, let's do our first step. Our first step was to find the area of the rectangle. So I'm going to do the rectangle area equals base times height. Okay, so our base is going to be the bottom down here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8 times the height all the way to the top is 1, 2, 3, 4, 5, 6. So 8 times 6 is 48 units squared. That is part of our answer. Remember, this time we're going to subtract from that answer. Okay, now let's find the area of triangle 1. Okay, and whenever we find that, it's going to be the same for all the others. Okay, so we have triangle 1. Formula is 1/2 base times height. So we have 1/2. I think we said our base was 2. Yep. And I think our height was 3. Let's check. 1, 2, 3. All right, so half of 2 is 1, and 1 times 3 is 3. So we have 3 units squared. All right, and so then triangle 2, triangle 3, and triangle 4 will all be 3 units squared. And I'm just going to put 3's. Kind of save us some time there. But we know it's units squared. Okay, we're going to need to then add up all of these, which would actually be the same as multiplying 3 4 times, right? So 3 times 4 is 12. So I'm going to write over here what we actually did so that when we write our expression, we'll know. So 3 times 4 was 12 units squared. Now we're going to take our total for the whole square, the whole rectangle, and subtract. So we have 48 units squared. Subtract 12 units squared. Okay, I'm going to try do this without setting it up. 8 minus 2 is 6. 4 minus 1 is 3. That's the same answer we got before. Perfect. That's what we wanted. We got the same answer over here. Okay, now we have to write an expression. Okay, I think we can do it. Okay, so first we found this, and we did 8 times 6, right? Then we did this, and we took it times 4, because we did this 4 times, 1 for each of them. Okay, and then we subtracted. So let's write that out. Okay, I'm going to put it kind of over here. So we had 8 times 6 that we started with, and then we subtracted, and we don't have to really put it in parentheses because we're going to multiply anyway before we subtract. Okay, and then on this side, we had 4 of these right here, right? So we had 4 of the 1/2 times 2 times 3. Awesome. Awesome. So this is our expression that we used to find the area of this one. Now let's look at these two. A little bit different. I think the biggest difference that I notice is in the first one we added and then the second one we subtracted. Here's why I see that. Because here I made them smaller and then put them back together. So I had to add them back together. Here I made it bigger and then took the parts away. So that tells me why I added or subtracted. And I like that we had our expressions, the little ones that we did for the formulas, and then we did them multiple times because they are the same for multiple different shapes. Very nice. Any questions that you have on finding the area or perimeter of polygons on the coordinate plane, put them in your ISN and we'll talk about them tomorrow.